A warm welcome to my lecture series. 13 different lectures are planned in this video series. So you can take this as a 13-day challenge. So each of the lecture, if you try to go through patiently, and also if you have a laptop, install the software, try to spend the time along with the video, I'm pretty sure the knowledge, what will you gain at the end of 13 days will be really tremendous. This video series highly focus on the people who are just starting their career or beginners in embedded C, and also the people who are having just some intermediate experience. I try to involve various practical scenarios, trying to give you some really good, insightful knowledge on embedded C and also on microcontrollers. So this video series tries to primarily use two different platforms. One is Code Composer Studio, which is an free integrated development IDE. It's a free tool which primarily focus on C2000 microcontrollers. So these are C2000 microcontrollers are one family type of microcontrollers which highly focus on power electronics applications, namely digital power and motor control. The next one is Visual Studio Code. So why Visual Studio Code? Because it's again a Microsoft provided IDE. It will really help you to write your own code, do some debugging without even having some hardware. You can try to test your code. That is a motivation behind the Visual Studio Code. And also, once you try to use a different platform, you will try to understand what all things the other platform is giving you for, like which is coming just like that. Without having much understanding, we'll try to use it. But once you have another tool, you'll try to understand, like what all features this particular tool is providing for you. So we will discuss the 13 different lectures with these two different platforms. So before going to the video, I highly recommend you to install these two softwares. One is the C2000ware software development kit provided by Texas Instrument. So you can see this to C2000ware. So it consists of digital power and the motor control SDK. So the different hardware, like different microcontrollers, what they are supporting is given over here. And also it gives you the different reference design with some code. With some code also it is given in the examples. So you can download, and then once you install, you can see a folder like this is the default location folder where you can try to see this software. So C2000. So if you try to go to C2000ware, you can see different subfolders which are being created. So the boards consist of the different experiment kits, launch pads, TI designs, etc. Here I'll try to focus on two different topics. One is the device support. So the device support is like the C2000 supports various devices like 28335, which is a little bit old controller, 28234, which is also an old controller. If you see 28002, 280015, which are the newest some controllers which TI have launched recently. So the examples, whatever I'm trying to give is applicable for any of the controllers. It is just applicable to any of the controllers. So if you try to go to F2823, you can see common docs, examples, headers. So mainly we will try to, like if you want to see some examples of this particular microcontroller, then you should go to like this particular location. If you want to see some headers, you can see the different headers. Different headers is also available. So so these are the two, or like the different subfolders what you can see here. And then what I try to suggest you is the Visual Studio Code. So you can try to so there are like various videos you can try to find out. So you can just download for Windows, and then you can also try to check any installation videos, what all things you want to install to write your own C code and debug. I will try to show you some like step-by-step process what is involved uh, to to do with Visual Studio Code in the coming video lectures. So basically, these are the tools which I would like to take up for this video series. So before going to the topics, let's try to lay down the foundation of this particular course. So there are basically data types in C. So if you try to see, there are primitive data types. So primitive means something, primary, or which is available from starting. So whenever you try to write something, you should try to think what is the reason behind that, or what is the name behind that. Such things you should try to ask yourself. And nowadays, like, everything is available. You can use Microsoft Copilot or ChatGPT to ask your doubts, and it will clearly point out like, this is what it means. But the question you should try to ask yourself, you should not take anything for granted. So primitive data types. So int, float, double, char, and void are the primitive data types. Derived data types. So the name itself, it says derived, means it is derived from the primitive data types, right? So the structures, arrays, pointers, unions, and enumerations. I'll try to discuss about structures, unions, and enumerations. Pointers, we have some detailed lectures coming up with respect to the pointers. And then we will also talk about the user-defined data types. So creating a new name for an existing type is nothing but the purpose of typedef. And then we will try to understand what is enum. It creates named integer constants. So if you want to give some names to some integer constants, you can try to use enums, right? So primitive data types. So int, basically it stores integers. It will only store integers. So int y is equal to 20.5, still it will store only 20. It will not store the decimal part of it. Float, it stores single precision decimals. Like, let's say z is equal to 2.3, then you can use float. If you need more decimals, then you should try to use double. Char stores a single character. Void, so normally if you you'll use some void when you are not having any return type, then you will try to use void. So double precision, what is double precision means? Basically the double data type, the moment when you try to write double, the number of data bytes, 8 bytes of data is used, for particular, if you say double X or double set, so the set will have a size of 8 bytes. So that is nothing but 64 bits, in which 11 bits are used for representing the floating values. Whereas the float data type uses 4 bytes of data to store a number. It uses around 8 bits for representing a floating value. So let's try to understand what is structures. So structures in C and its declaration, right? So first of all, why do we need structures, right? So if we want to combine the different data types under one name, structure is used, right? Let's assume that you are having different data types in the char, against inside structure, another structure, different data types. Then you can club everything under one structure. So that is the purpose of having a structure. While declaring the structure, memory location is not allocated. Please understand, whenever you try to just write like this, the memory location is not allocated. Structure declaration tells how does the structure element look like. It just says, okay, this is a structure, and how does each and every element looks like, or what all elements are there inside the structure. The elements in the structure are part of the group, right? So the elements are the part of this group. So if you try to see the example from the peripheral header, you can try to go to this particular location. So let's try to go to device support. Then you can go to any of the device. Then let's try to headers. If you try to go to include, then you can see the various the various header files are coming up. So so you can here you can see the different structures, right? So let's say structure GPA CTRL bits. So what does it says? It consists of 4 different elements. Each element is of 8 bit. So that's what it means, right? So that is the purpose of structure. So you can go to any of the device. You can go to 28005 everywhere. The location is same. So you go to headers and then include. So depending upon the microcontrollers, some peripherals will increase, some peripherals will get reduced. So then basically the number of header files will increase or reduce. So all these header files, you take all these, any of the header files. So each and every header file, basically, you see, it defines different structures, declares different structures. So now we talked about structure declaration. Let's try to understand what is structure definition. Two ways of structure definitions. One is during the structure template declaration itself. So let's say that struct name, you're trying to say height, weight. So these are the different elements. So Manoj and Karthik. So Manoj is a structure, a data type of which consists of 2 different elements. Karthik is also another variable which consists of, or which is having 2 different variables inside it, height and weight. So this is during the structure template declaration. After the structure template declaration, so let's assume that if you want to have something like after the structure template declaration, then what we will do is we will just write the structure name and then like this struct name Manoj Karthik. So so basically so this is trying to say that there are 2 different name variables under with the same struct name data type, right? So if you try to see this, where we are defining the structure, so you'll be able to see there is some file called global variable defs.c where you can see the structure definition which is happening. So unless otherwise you define a structure, like the memory allocation is not done. So only when you define your structure, you can see the memory allocation will be allocated, right? So now let's go to the next topic. So that is nothing but union. So union data type? So what is union? All the members in the union are stored in the same memory location, resulting in only one member containing the data at the same time. So if you try to see these GPS CTRL bits, so we are saying that this union consists of 2 different elements. One is this all, and then we are saying that GPS CTRL bit, right? So this union consists of 2 different elements, all and as well as GPS CTRL bits, bits. So we are trying to create an instance of this GPS CTRL bits, right? So what is the size of the union? The size of the union is the size of the largest number. So if you see, this both are 32 bit. So the size of this structure is having 32 bit. And the location, the memory location will be the same. It will not have separate memory location. So if you try to see the struct is having separate memory location. So the call PRD0, it is having 8 different bits, and then next 8 bits, it goes on. But when you try to see the GPA CTRL rec, it's just the 32 bits. It will only have 32 bits. So that is the purpose of union, right? So what is the usage of union in our case? So basically, if you rather than accessing single bit, if you want to write the whole 16 bit, then basically the union is used. So if you see, if you take any of the files, you can see the union is getting used in all your structure declaration, right? So that is the purpose of the structure declaration. Nesting of structure, so which is not much complex. So inside a structure itself, if you want a different structure, then basically it is called as nesting of structure, right? So let's say that you have some struct.Kerala, struct.Tamil Nadu, right? So like, okay, here I've given the same elements, but you can have a different elements as well. The struct state, so the state consists of Kerala, KL, Tamil Nadu, TN. Then basically, like if you try to create an instance states ST. So okay, now the ST is the data type you have created. So ST dot KL dot population. So ST consists of Kerala and Tamil Nadu. You can choose KL or TN. And in KL, you can choose any of the three elements. So that is the purpose of the structures or the nesting of the structures, right? And there is something called the enumeration data type. So this enumeration data type is a user-defined data type in C. So it's a user-defined. It is mainly used to assign names to the integral constant. So if you try to see this type def enum, I try to write type def. Yeah, like so. We'll try to discuss what is type def in the next lecture. But basically, we are trying to give some rather than giving some constants 1 2, you are trying to give some names. So that's what it means. So if you try to say type of enum, which consists of two different elements, and you created the data type name as GPO direction. So the GPO direction, you try to create a like a variable called GPO dir, so which is the like a data a variable which is of data type GPO direction. Now you can assign the GPO direction like any of the two values, either GPO dir mode in or mode out, right? So in the same way, you can try to like have different enums, and then you can try to pass the values to the integral constant. So that is the purpose of having an enum data type, right? So you can see this enum data types is widely used in the driver library, which we'll try to discuss in one of the subsequent lectures. So the last point, what I want to discuss in this lecture is the type def. Like the type def is used to redefine the existing data type. So let's say that type def char, if you want to use some other different name, then you can use, like you can call with this char, right? Type def in structures, normally structure declaration is given initially, right? So we'll give the structure declaration, and definition is given at a later point of time. While defining the definition, we have to use the keyword struct again, right? So if you are like, if you really want to like have the just the structure, so which we have seen, like here you can see the structure. So you again you want to give the name as struct, then only you can really like create an instance of this name of like the name instance shall be created, unless otherwise if you are not using the struct keyword, you cannot use it. So if you really don't want to again use your like the keyword struct, then just have a type def. So you are saying to say that, okay, I'm redefining my existing data type. Like, so I'm trying to have my own user defined data type called name, which consists of two different elements, height and weight, right? So the memory allocation, so which we try to discuss, is allocated only when the definition is made. And then we will also talk about the hash pragma section, like so GPU control rec. So we are trying to have a like the structure we are trying to assign in one particular memory location. So and then this volatile struct also we'll try to discuss in the coming lectures. So basically, this lecture series, I try to take some information which is available, which is publicly available to everyone. Like the VS Code, it's free software. CCS, it's free software. See, whatever the topic I'm trying to talk is also the general topics which is normally available. But what I'm trying to do is consolidate the data and try to ramp up your knowledge in a very short span of time. So if you are really interested to listen the further lectures, I highly recommend you the 13-day challenge. With the 13 days challenge, if you try to travel with me, I can give you surety that you will try to learn something new, which is a guarantee which I would like to give you. Thank you all. We'll see you all in the next lecture.